Good morning, dearies. Happy to be back. I hope you will enjoy this session. Today, I'm going to explain the math book that we are going to use. The book that we are going to use is Mathematics Textbook for Class 9 by NCRT Publications. The topics that we are going to see throughout the year are in the slide. Our session usually starts with a starter activity, and today's starter activity is a value based learning on a sweet story of love and time.
Love and time. Once upon a time, there was an island where all the feelings lived: happiness, vanity, sadness, knowledge, and love. One day, it was announced to the feelings that the island would sink. So, everyone constructed boats and left, except for love. Love was the only one who stayed. Love wanted to hold out until the last possible moment. When the island had almost sunk, Love decided to ask for help. Richness was passing by in a grand boat. Love said, "Richness, can you take me with you?" Richness said, "No, I can't. There is a lot of gold and silver in my boat. There is no place for you." Love decided to ask Vanity, who was also passing by in a beautiful vessel. "Vanity, please help me." "I can't help you, love. You are all wet and might damage my boat," Vanity answered. Sadness also passed by. So Love asked, "Sadness, please let me go with you." "Oh, Love, I am so sad that I need to be myself. I can't take you." Happiness also passed by, but she was so happy that she did not even hear when Love called her. Suddenly, there was a voice. "Come, Love, I will take you." It was an elder. So blessed and overjoyed, Love even forgot to ask the elder where they were going. When they arrived at dry land, the elder went his own way. Realizing how much she owed to the elder, Love asked Knowledge, another elder, "Who helped me?" Knowledge answered, "It was time." "Time? But why did time help me?" Knowledge smiled with deep wisdom and answered, "Because only time is capable of understanding how valuable love is." Moral: time heals everything. Time is very valuable.
I hope you enjoyed the story. Let's get into our math class. Today we are going to start a new topic, chapter 1, number system. We know math is all about numbers. Everything that you learn in mathematics is nothing but different forms of number patterns. Actually, not just math, but all physical phenomena and natural phenomena, everything can really be explained using numbers at a pattern. So these number patterns are at a very core of all math or all nature, right? Let's look at a very simple number pattern. Let's say 1, 3, 5, 7. What are these? If you look at them, they are nothing but odd numbers. Now, you could visualize them as trying this one triangle. This is three triangles. If I divide it further, this will be five triangles. Here, seven triangles. Right? So, if I want to divide a triangle into each part in two equal areas, the number of the triangles I will get in each row is going to be an odd number. Right? This is one way to visualize it. Now let's add them and see. 1 and 3 you will get 4. 4 plus 5 you will get 9. 1 plus 3 plus 5 plus 7 you will get 16. What are these? Nothing but square numbers. Why do you get square numbers? Because adding a triangle gives you squares. When two triangles make up a square, which is why adding these triangles that represented a triangle gave you a square. So it's just one way to see it. So there are multiple ways in which you can visualize simple concept of triangles and squares. Actually, it links numbers, geometry, algebra and everything that is so fascinating. These number patterns are so fascinating that you will start visualizing number patterns, they become extremely fascinating. This is nothing new for you. You already learned number patterns for a very long time. Now, in fact, what is the very first thing that you learn in math? It's nothing but a number part. The first thing that you learn in math is nothing but counting numbers. So you used to count 1, 2, 3, 4, 5. Nothing but the number line. We also have a name for it called as natural numbers. So there are number patterns that you have already known. A very basic pattern is natural number. So if you add 0 to it, it becomes whole number. The negative numbers which are added will constitute integers. Why so they are called whole numbers or integers? Let me take a basket. There is one apple, here three oranges, four fruits in total. Now, what if we want to represent what is left in the basket? We could represent fruits using natural numbers. How do you represent what is left in the basket if there is nothing? How do we show nothing with natural numbers? You can't. That is why 0 is added. So if you add 0 to the set, it becomes whole numbers. And so the whole number becomes 0 to infinity, which is represented by W. Again, let's see the numbers with negative numbers. If this is so, if we add two numbers, we get whole numbers. But if we subtract, we get negative numbers which are called integers. So these negative numbers are represented to the left of the number line. So the natural number when added 0 becomes whole number, and when whole number when added negative number becomes integers. As of now, we have seen different types of numbers that we know already. Now, we are going to see the two basic types of number system with real life examples.
Hello. Let's discuss about number system. A number system is a collection of various symbols which are called digits. The two types of number system are binary number system, decimal number system. Here we can see that light has only two options, that is on and off. In the same way, binary number system has only two different symbols that make up its number system, that is 0 and 1. Here we can observe that in TV remote to have different channels 2 digits are not sufficient. So we have decimal number system which has 10 digits. We have channels from 1 to so on which can be called as natural numbers. If we include 0 to our natural numbers, they are called as whole numbers. To represent very cold temperatures, our whole numbers are not sufficient. If we include negative numbers to our whole numbers, they are called as integers. If we have numbers which can be written as pairs like teddies in playground, these are called as even numbers. That is numbers exactly divisible by 2. The other numbers are called as odd numbers. That is numbers not exactly divisible by 2. In real life we need to represent numbers in other formats also. For example, if we are having a chocolate, it can be written as 1. If we break into 2, each part can be written as half, that is 1 by 2. If we break it into 4 pieces, it can be called as quarter, that is 1 by 4. These type of numbers are called as rational numbers.
I hope you have understood of natural numbers, integers, whole numbers, etc. Now, these are the topics that we are going to see in number system. Rational numbers, irrational numbers, real numbers. And these are the numbers that we see in detail and how to represent in the number line. And these are the technical words used in this chapter. Let's see the definition of each.
All right, everyone, let's go ahead and take a visual journey through the universe of real numbers. So the first set of numbers is called the natural numbers, and this is also called the counting numbers. Think of it like counting on your fingers, and this set starts with 1, and then 2, and then 3, and then 4, and then so on and so forth, on and on and on, in a positive direction. Now, those natural numbers are a subset of the set of whole numbers. Now, whole numbers is the same thing as natural numbers, except that 0 is also included in that set. So it's 1, 2, 3, 4, 5, and anything else going on and on and on in the positive direction, but it's starting at 0, whereas the natural numbers start at 1. Now, the whole numbers are a smaller subset of the integers. Now, what integers are, all of the natural numbers and 0, so all of the whole numbers as well, and their negative counterparts. So now we move on forever in a positive direction and a negative direction here. And all of these are subsets of the greater universe of rational numbers. Now, the rational numbers will fill in the gaps in between those integers on the number line. In this case, any number that can be written as a fraction, a over b, where a and b are both whole numbers here. And an example would be 1/2. Now, this does not actually cover every possible value that can be found on the number line. We can ask ourselves, what about the numbers that can't be written as a fraction but still exist on that number line? This would be the set of irrational numbers, and examples would include pi and the square root of 2, since 2 is not a perfect square. Such irrational numbers do exist on the number line, however, they cannot be written as a fraction the way that a rational number can be. Now, we notice that there is no overlap between the rational numbers and irrational numbers, since no number can be both rational and irrational at the same time. And both of these sets of numbers are covered under the umbrella of the real numbers. So a real number is anything that can be found on that number line. And visualizing this universe of real numbers should really help us to understand when we see that phrase, all real numbers. Keep this in mind moving forward, and it'll make things much easier for you. And don't those colors look nice?